Welcome to the Calsoft podcast series. This is your host Mark Rodrigues. In light of the upcoming DockerCon, we have another topic today, which is going to be titled Docker Networking 101. I have with me today Rishikesh Pataskar, who is a principal development engineer at Calsoft.
Hi guys.
Hi. This podcast is going to be hosted today by Nitin Singhvi, associate director here, who just spoke last week about another Docker podcast. Hey Nitin.
Hey. Hi Mark.
So let me introduce Rishikesh and then I'll hand it over to Nitin. Rishikesh is a principal development engineer here at Calsoft. He has designed and implemented Linux kernel drivers and user-space system software and REST-based APIs for various applications. He's now working on the Docker environment here at Calsoft. So I'm going to pass this on to Nitin.
Hey, thanks Mark. Hi Rishikesh, how are you doing?
Good. How are you, Nitin?
Thanks, I'm doing good. So Rishikesh has been working on the Docker networking side of the late. So I'm just trying to get some understanding from him around what he reads up on the Docker networking, what he sees the future to be, how's the current Docker networking progressing, and so on. So Rishikesh, my first question is: does Docker provide native container-based networking capabilities in any form?
It does. It supports networking across containers on the same host out of box. From version 1.9, they also support multi-host networking, so containers across multiple hosts, networking across them is supported out of the box as well. By default, Docker installation comes up with 3 networks: a none network, a host network, and a bridge network. The none network basically means your container doesn't have a network. Your container comes up with a container specific network stack. The host network gives the host networking stack to the container, and the bridge network is a representation of the default Docker 0 network, which is present in all Docker installations. This is the network to which all your containers are attached by default.
Okay, excellent. So are these the only networks available which users can use, or how about the multi-tenancy on the same Docker machine?
You can create your own networks. You can provide network isolation for containers by creating your own networks. Docker provides some network drivers which can be used by default. So they have the bridge network driver, of course, with which you can create a bridge network for communication across containers on the same hosts. You can also use an overlay driver for multi-host communication. They also provide a plug-in capability where you can write your own driver, which will act as a remote driver for your network.
Okay. So is the communication between the containers on the same network established automatically?
Using IP addresses, yes. For service discovery, that is automatic service discovery, if you're connected to the default network, automatic service discovery is not supported. You need to run the legacy docker run -- link command explicitly. But if you have a user-defined network, then those containers on that network can immediately communicate with each other. The Docker daemon runs an embedded DNS server to provide this sort of service discovery.
Oh, okay. Excellent. I actually am impressed. You remember the commands also. That's pretty awesome. So how does the bridge network work? If you can explain that in a bit more details.
Right. So at its foundation, it uses virtual interfaces, which are actually 2 interfaces bonded together in a pair. In the case of containers, a virtual interface created inside the container is linked with one on the host, which is how traffic moves across the container and the host, or between the container and the host.
Okay. You talked about the overlay network or the remote drivers using the overlay networks. So what is the overlay network being used with Docker 1.9?
That's for multi-host connectivity support. That's the native multi-host connectivity that Docker v1.9 supports. It's established with the support of libnetwork, which is a built-in VXLAN based overlay network driver, and libkv, which is Docker's key value library. libkv works with multiple key values backends like console, etcd, and zookeeper. Overlay network basically requires a valid key value store service to which all hosts should be able to communicate. libnetwork implements the container network model, which is CNM.
Wow, CNM. So there's a new terminology now that we have. Uh, can you explain a bit about CNM itself? What is CNM?
Right. It's a formalization of steps which are required to provide networking to containers, and at the same time it provides an abstraction to support multiple network drivers. Those are the plugins that I was talking about, where you can have multiple network drivers to create your own containers. It's built on CNM is built on three main components: sandbox, endpoint, and network. The sandbox represents the configuration of a container's network stack. A Linux network namespace is a possible implementation. An endpoint joins a sandbox to a network. The V pair that we talked about earlier is an endpoint. A network is just a group of endpoints that can communicate with each other. The bridge, a Linux bridge to be specific, is an example implementation.
Okay. So I have this confusion. How the automatic service discovery works in the overlay network?
Right. So if you remember the key value store that we talked about, to which all the hosts need to be connected, that's where this comes in. Through the key value store, Docker hosts learn and advertise all information for service discovery at the management plane level. The hosts can directly communicate host map mappings via gossip-based protocol to form a distributed control plane as well. So the key value store basically has all the information about the network.
And how is the connectivity established between the overlays?
A bridge is created. I don't remember the exact name. I think it's Docker Gateway, to which one end of a VETH pair is a virtual interface pair is attached. The other end can be found in the container, which is just like your regular bridge network. The container itself, however, has two interfaces. One is the interface that we just talked about. The other is used for intra-host communication on the overlay network.
Okay. A couple of times in your previous responses, you talked about the plugins. So it looks like the CNM, right?
Yeah.
So CNM provides the capability to write, somebody's own custom plugin. Is that correct?
That's right. So it inherently provides an abstraction for multiple network drivers. A network driver plugin makes use of Docker's own plugin infrastructure. They also provide this infrastructure for volume and authorization plugins. In this infrastructure, the plugin is a process running on the same host as the Docker daemon. A couple of examples or a few examples of this are Contiv, Calico, Curate, Weave, which are some popular network plugins for Docker.
Excellent. So how are these plugins implemented? Meaning, is there a well-defined process, well-defined framework from Docker which can be used, or there are some hacks which one need to do?
It is a well-defined process actually. So each plugin is implemented as a remote driver for libnetwork, which shares the plugin infrastructure with the Docker engine. There is a specified discovery mechanism for all these plugins, and this discovery mechanism kicks in whenever a user or container tries to access these plugins by looking for them in the plugin directory. So there are also predefined plugin directories for Docker. Network plugins specifically implement the Docker plugin API and the network plugin protocol. The API is an RPC style JSON over HTTP. All of these are HTTP post requests. The plugin needs to implement an HTTP server, since requests always go from the daemon to the plugin. The remote driver protocol, the network protocol that we talked about, is a set of HTTP post RPCs or remote procedure calls with JSON payloads. The driver is expected to respond with a JSON payload as well, but however it can also be a blank response, so there's that flexibility. Docker also has an SDK for network plugin development.
Okay. You made it sound like very well defined process, but I'm sure there would be hacks when we have to implement something in there, purely because it's a new thing. Docker 1.9 is pretty recent. All right. So so Kubernetes and Mesos also do clustering of the Docker hosts. I'm wondering if these K8s and Mesos also use Docker 1.9 or CNM, or they have something completely different?
Right. Prior to the point of time when Docker actually supported multi-host networking natively, Kubernetes had its own mechanism for setting up multi-host networking. They actually, the plugins that we spoke about, like ViewNet and Calico and some of the others, also work with Kubernetes as plugins. So those can also be used to set up multi-host networking. So networking across your containers in the cluster. But Kubernetes, now that Docker supports native multi-host networking, Kubernetes hasn't adopted that CNM framework just yet. But they don't restrict users from setting up and managing the necessary infrastructure like the key value store. So if users are willing to do that, they can just get Docker networking to work. As of January 2016, the Kubernetes network plugin system still retains its alpha status. As far as Mesos is concerned, it defaults to host networking when it runs a Docker image. For network isolation, starting 0.23.0, Mesos has implemented IP per container for the native Mesos containerizer. They are planning on Docker support in the near future.
Okay. So moving to OpenStack a bit, with the Magnum project, I think OpenStack is making Docker and K8s available as the first class resources. Where is the Docker networking in that setup?
There is actually an OpenStack project for this called Curate. The goal of this project is to provide the ability to use Neutron plugins with libnetwork. So it's essentially a translator between Docker CNM, the container network model, and Neutron's networking model, which is its set of APIs. It also acts as a libnetwork IPAM, an IP address management driver.
Excellent. So I think that's a good amount of information on the Docker and container networking that you gave, Rishikesh. Thanks for that. One more question. So DockerCon is coming up next week. What's your expectation from DockerCon this time?
Well, one of the talks that I'm looking forward to is the networking ecosystem talk, which is going to be given by some of the people at Weaveworks. They're going to be talking about, I think it's titled "The Good, the Bad, and the Ugly" for microservices networking, which will be a good talk, I think, just because there'll be a lot of production issues and things like that which will be discussed, and that should be interesting as far as roadmap of Docker networking and container networking in general is concerned.
Okay. Well, thanks guys. Thanks Rishikesh. It was great to have you on the show.
Thanks, Mark.
Nitin, thanks for hosting this. You just proved that you can do well on both sides of the chair.
Thanks, Mark. My pleasure.
So it's a wrap from us here on this topic. If you would like to meet with these guys at DockerCon, send us your feedback and we'll set up a meeting. Or you can write to us at marketing@calsoftinc.com. Thanks for tuning in and listening to us. Thank you and have a great day. Bye-bye.